Hi there! With this video I want to help you understand how relative and absolute cell referencing works in a spreadsheet such as Google Sheets or Excel. I will explain what a cell reference is, how it works, and what it's used for in a spreadsheet by demonstrating it in a couple of examples. As a beginner it feels difficult to fully understand this concept, but once explained in a simple and an easy way, you will master it, I am sure. So let's get started. What is a cell reference? A cell reference is a way of identifying a specific cell in a spreadsheet. A cell reference works a little bit like map coordinates, identifying a location or a position on a map. In the same sense, a cell reference consists of a column letter and a row number, such as, for example, D5 or B12 or even F9, identifying the location of a cell in the spreadsheet. You see that each cell has a unique cell reference or location. And in a spreadsheet, cell references are used either to just refer to the data contained in that specific cell, or for example, in a formula to capture and use the information that is contained in that cell. It is like giving directions to Google Sheets, telling it where to find the data you need to fetch for the calculations or the analysis. So in this example, I entered the text cell D5 in the D5 cell, and I entered the number 100 in the cell B12, and my first name in the cell F9. Now when you click on a cell, for example D5, it gets selected and the row and the column gets colored, as you can see here. With the cell selected, you can read the cell reference up here on the left of the formula bar, where the content of the cell is shown. The same applies for every other cell. You can see it change whenever selecting another cell. Cell referencing is really a basic building block for a spreadsheet, and especially for creating formulas, allowing users to dynamically interact with the data. And that is why it is important for us, spreadsheet users, to understand this concept 100%. Now, let's take a look at how referencing is used all of the time in the spreadsheets. In this example, where I want to calculate my sales of fruits, I have a simple table with the different products that I'm selling, the quantity sold, and the price of each item. And I want to calculate, for example, the total amount of sales. Obviously, I need to multiply for each item the quantity sold with the unit price and then make the total of the amounts received per item. So in the cell E3, I can type in the formula, and formulas always start with an equal sign. So equal C3, and the user interface already gives me a preview of the result, as you can see. So C3 times, with an asterisk, D3. So in this formula, I refer to two other cells to make a calculation. And if I hit enter, I will get the result. And now if you select again the cell E3, you see the outcome of the formula in the cell itself. And you can see the cell reference number up here. And the formula is using two other cell references in the formula bar. Now pay attention. There are basically two primary types of cell references: the relative cell reference and the absolute cell reference. By default, all cell references in the spreadsheets are relative references. The term relative in a relative reference basically means that Google Sheets looks at the relative position of the cells in regard to its own position. And that is what happens in cell E3. Basically, what the formula in the cell E3 is saying to Google Sheets is to multiply the value of the cell, two cells to the left, and that is C3, with the value of the cell, one cell to the left, and that is D3. So it tells Google Sheets, look up the values in those cells with the relative position in regard to its own position, two to the left and one to the left. Now, one of the most powerful features of spreadsheets is the possibility to copy and move information, but also formulas across different cells and to perform calculations across large data sets. As you know, copying information is done very easily by selecting the cell and dragging the blue circle to the adjacent cells. For example, with this text, I simply select the cell and I drag it down to the cells below. Okay, let's undo this. Now with a formula, I can do this too, and that is obviously what I want in my sales table. With a lot of products, I don't want to type in the formula X number of times, of course. I just want to simply copy the formula. So when I drag the formula in E3 down, E4 and E5 are calculated. The relative references to the cell C3 and C4 in the formula in E3 will change when I copy the formula to another cell. The references will change and adjust accordingly to the position where to the formula is copied. So as you drag down the formula, the cell referenced in the formula will move the same number of cells up or down and left or right relative to the cell where the formula is in. In other words, if you drag your formula down 2 cells, the reference cells will also move down 2 cells. But in the end, the formula will always be multiply the value of the cell 2 cells to the left with the value of the cell 1 cell to the left. So if I select now E4 or E5, I can see that this is the case. In E4, I'm working with the values in C4 and D4, and in D5, the reference cells are C5 and D5. And this way of adapting the formulas is really the backbone of creating dynamic and functional spreadsheets. Relative cell referencing is like giving directions to Google Sheets about where to search specific information based on in which cell you are standing. If I would copy the formula in E3, for example, to H12, the formula will change to F12 times G12. These cells are empty, so the result is 0, but the formula is still multiply the value of the cell 2 cells to the left with the value of the cell 1 cell to the left. Let's take a look at the result when I drag the cell E5 with its formula to the right, in F5 and G5 and so on. It continues to multiply the value of the cell 2 cells to the left with the value of the cell 1 cell to the left. So F5 is D5 times E5 being 10 times 70 is 700, and G5 is E5 times F5 being 70 times 700 equals 49,000 and so on. And this is what makes a relative reference relative. It adjusts the reference according to the position whereto the formula is copied. Now remember, all cell references entered in the spreadsheet are relative references by default. Now, in some cases, it is handy that the reference does not adapt when copying a formula, and then we use absolute referencing. An absolute cell reference means you can lock your reference cell to stay exactly where it is and always point to the same and exact row or column described, regardless of where the formula or the reference appears or is copied to. So let me show this in an example. Imagine that I want to include the sales tax into my spreadsheet. So with the products, quantity sold and the price mentioned, I can create a formula in E3 and drag it down as we have demonstrated a few minutes ago. So let's do that. Now to calculate the tax, I will take the total and multiply it with the tax rate in the cell I3. So in cell F3, this cell is equal E3 multiplied with I3, and I hit enter, and the calculated 10% tax on the total sales of the apples is 3.5. Now if I want to use the formula in the other cells and I drag the cell with the formula down, ouch, the results are incorrect. So let's take a look what happened to the formulas in F4 and F5. As you can see, due to the relative referencing, the cell was adjusted according to the new position of the cell that holds the formula, and this is not what we wanted in this case. Now, to avoid this, we will use absolute referencing, meaning that I will lock the reference cell I3 to stay exactly at I3 when copied, regardless of where the formula or the reference appears or is copied to. And the way to do this is by putting a dollar symbol before the column letter and/or the row number in the reference I want to lock. So for example here, I3, if I want to lock the reference cell I3, I can enter a $, I, and a $3 in the formula. And then when the formula is copied down, the reference cell I3 in the formula will not change at all and stays I3. It is possible to lock only the column by adding a $, only before the column, and it's possible to lock only the row by adding a $, only before the row of the reference cell. A quick way to make a reference cell an absolute reference is to press F4 immediately after selecting a cell to add to your formula. And for Mac users, this is to press the Fn, the function, plus F4. So here in this case, only locking in the row of the field I3 by adding a $, before the 3 of row 3 would have worked too, because when dragging down the formula, the column is staying the same, and I want to have the row 3 fixed. This is sometimes also called mixed cell referencing, mixing relative and absolute referencing. And I can complete the table by adding the formula in G3 and copy it down. Just like that. Okay. I really hope that cell referencing is now 100% clear to you. And again, thinking about relative cell referencing as giving Google Sheets instructions based on your current cell location helped me a lot to really grasp this concept. So if you do the same, you will do just fine. One last tip. It is always a good idea to double check your formulas with sample data to ensure that they are working as intended. So give this video a thumbs up and a comment below if it was useful to you, and subscribe to see more videos like this one. Bye.